so I'm going to talk about an announcement I made, or like a visualization I made about 2 years ago for visualizing Citi bike data. So basically, I want to start by just showing you guys what it looks like. It sort of looks like this. I just took a day of Citi bike data and mapped all of the trips onto a Google map, so you can sort of visualize where bikes are actually going throughout the day. And then look at them by different demographics of the people that are riding them. So what I want to talk about first is sort of like how I built it, and then more about the sort of insights that I got from it. So the basic summary is that I took a single day of data, which I chose somewhat randomly as December 1st, 2016. And I looked at every single ride that day, and then I mapped I knew where they started and where they ended, and I just mapped them along the Google Maps recommended route for bikes. And then I just drew the trips because I also knew how long they took. I just drew them at their average speed going along that route. So basically my motivation for making this was I thought it would be interesting, and I knew that Citi Bike provides tons of data. So what Citi Bike actually provides, like going back through all the history of Citi Bike, if you don't know this, they provide all this information for every single trip, and they make it a downloadable CSV like a month after the fact. So it's like a creepy amount of data. They will give you absolutely everything. So I was like looking at all this, and I'm like, okay, what can I do with this information? And basically what I used is the trip duration, the station latitude, longitude of where they started and where they ended, and then the demographic information, so the type of user, the gender of the user, and the birthday. Or I just could do birth year, not actual birthday. So it is actually fairly straightforward to map the trip. I used the Google Map Direction Services API. I sent this request in JavaScript, and I just passed in the latitude, longitude, where I started and where I ended each trip. And I told it I was on the bike. And basically it gives you back a bunch of stuff, but the most important thing is the total distance of this route and the path object. So the path object has a list of all of the inflection points on the route. So what that means is like any time that you even slightly change direction that you're facing while you're going. So even if you think New York is a grid and you're going straight, you're actually not, as far as like globe is concerned. So there's a lot of inflection points. So this path object returned by Google Maps has every single one of those in like an array of latitude, longitude points. So I had those, and then I also knew from Citi Bike how long each trip took in seconds. So it's pretty easy to get the average speed of someone's trip. If you're like, okay, they went from here to here, it was 1 mile, and it took them like 3 minutes or something. So I was like, oh, this is going to be so easy. I'm just going to animate from each point, like divide by the average speed, and like throw them on this map, which sounded great. And then there was one problem that I realized pretty quickly, and it was roundabouts. Okay, so basically, I was looking at this one trip that was happening in the middle of the night while I was starting this, and it was like a guy going down Central Park West and then around Columbus Circle and continuing down. He, like, in my original animation, zoomed down like the entire length of Central Park and then moved along like a snail around the circle because of how many inflection points there are. So based on how I set this up, it was not actually representing the average speed of your trip correctly. So what I ended up doing is calculating the time between the point that you're at in one step to the next inflection point as a total distance of your trip, and then use the math to basically set that as the average speed for that segment. And then it's pretty easy. So in my visualization, you saw all of the little circles was an individual bike. And it's just an instance of a Google Maps circle object, which is just like native to the Google Maps setup. And all I had to do is set the center and had the latitude, longitude coordinates. So you just literally pass this fun method called set center. And that's all you need to do. So if I go back to you can see it's just like a Google Map, so you can move around in it. And just start looking at where trips go. So you sort of see like, basically when you're looking at this in like default view, you see like a map of all the bike lanes because you're just looking at green dots moving, and most people are probably going from destinations along the bike routes. And then for each trip, like I said, I also have all this information about like what gender the person is. So this was pretty interesting, and one thing that I noticed is that if you start at this time around 7 in the morning, you mostly have men, and if we jump ahead to like 10 a.m., you see a lot more women commuting or riding city bikes in general. And then a little bit, so some more city bike space. And then I also looked at it by age group. So pink is Gen Z, blue is millennials, red is Gen X, and yellow is baby boomers. And there's a few unknowns, but for the most part, Citi has really complete data, so that was really fun. So that's basically it. And then what I also did was sort of look at aggregate data for the whole day. So you can see the majority, this is the number of trips taken all day. And the majority of riders are men on December 1st, 2016. You can also see actually women took slightly longer trips on average. But the average trip is only like, it's less than 13 minutes, the average trip distance, which is a lot shorter than I would think, because my commute is like 30 minutes. And what else can we look at? The number of, so subscriber is what Citi calls the annual members, and everyone else is a customer, whether you're like a single use or 24-hour or 3-day. But overwhelmingly, the majority of people that use Citi on this day were annual subscribers. But if you look at how long each trip was, the customers actually take way longer trips, which makes sense if you think like they're tourists, they're kind of going through Central Park, or they're going along the Western Greenway and they're enjoying their life and they're not commuting. And also look, actually the most popular station is this Pershing Square, which is right by Grand Central. Does anybody use this station?
No, because there are never any bikes on it.
The most popular by far for both pickups and drop-offs, at least on this day.
As a fun fact, that's also the station used for the Citi Bike fleet in the Citi float or the Gay Pride Parade.
That's a fun fact.
What was the question?
It's used in the Citi Gay Pride fleet. So so this is some other fun facts about that day. Basically, just general aggregate information. There was like 43,242 trips. The average trip was 12 minutes, 52 seconds. This is a picture of the Pershing Square location. And it was specifically Pershing Square North for both pickups and drop-offs. There's like 3 stations on this block, and it was that specific so they went ahead way more than the others. And the average age of a rider was 38. And actually, if go back to my chart, you can see the average age is like pretty heavily skewed towards like millennials and Gen X, right around there. But if you look at how long each person's trip was, the older they get, the longer they rode, actually. I don't know if they're slower or they're just going further. Yeah, that's basically it.
Did you consider doing it for more data point days, like a year later or even 2 years later?
It did, and so I made this project like in last spring, which is why I chose this date, and I was sort of like re-upping it for this presentation, and I was like, oh, I should really do it for this year. But the thing that gave me the most trouble with this is actually Google Maps API has a lot of query limits if you don't pay them a lot of money, and I kept hitting their query limits. So what I ended up doing, I saved all these routes in a Firebase database so that I don't have to hit their API constantly because they were not happy with it. So, yeah.
And why did you choose December 1st?
More or less at random. It's a Thursday, so I wanted a weekday that had like normal commuting. But other than that, it's random.
Was it a design choice or a technical choice to not the non-user paths?
For the like circles, it was a design choice. So showing like an individual person moving where they are, like. So now we're frozen at 1048. This is roughly where all the bikes were. So if you had a line, it would be slightly more opaque.
Last question.
How did you do the animation?
So this is just a Google map. These are all Google Map circles, and like I said, I just set the center of the circle to a new latitude longitude point. Basically, the whole map. I have like a clock, and it just tells all of my little circles what time it is, and the circle knows when it should be at which point in its map.
Do you mind mentioning which technology you used, whether it be JavaScript or...
So this is all done in JavaScript. Yeah, 100% JavaScript.
All right.